So good morning students. Today we are going to discuss about the architecture of software defined radio. So first we need to discuss about the evaluation of SDR. So first the SDR concept started in late 70s, okay, with some introduction of multi-mode radios that is operating in VHF band, okay, very high frequency band. So next, the US Air Force Avionics Laboratory that initiate the integrated communication, navigation, identification and avionics program. So in the late 90s in band like 30 megahertz to 1600 megahertz. So in late 80s, the Air Force Research Laboratory that initiates the processor like tactical anti-jump programmable signal processor. So they developed a processor that is capable of simultaneously waveform operations. So by using a modular approach, so it later evolved into the SpeakEC program. Okay, already we discussed about the SpeakEC in the history of software defined radio. So that's the evolution of SpeakEC program as well as the software defined radio evaluation. So what are the architectural goals of software defined radio? So first one is compatibility, then controllability, then predictability. These are the architecture goals of software defined radio. So what is compatibility means? Okay, the structure of plug and play modules that must be compatible, okay, with the software radio environment. Next, controllability means the modules may be controllable under model composition. So predictability, the model composition must preserve radio surface defining properties of system. So it can be controlled, it must not have an unintended consequences. Okay, this is the predictability. So why we need software defined radio means it is easily upgradable, low maintenance cost, it responds to changes in operating environment. Main thing why we are needing the software defined radio is it responds to the changes in operating environment, then it is reconfigurable. So what is the architecture? So the design of the software defined radio architecture is to improve the entire network utilization, okay, just rather than just link spectral efficiency. The main thing is improving the entire network utilization. So the software defined radio is a programmable transceiver, we already know that, with some capabilities of operating various wireless communication protocols without the need of change or update the hardware. So the architecture of software defined radio, the software defined radio is a programmable transceiver with the capability of operating various wireless communication protocols without the need of change of update the hardware. Okay, so this is the architecture. So we offer an overview of software defined radio architecture and its basic components. So then discuss the significant design and development tools. These are the basic architecture of the software defined radio. So first one, the concept of software defined radio, first developed by combined efforts of various research groups in private as well as government organization in US. First, it's originally developed in US in 1970s, in 90s, 80s in the period. So next, the software radio. First, the software before that, software development radio. First radio is software radio and cognitive radio. So the software radio platform that processes almost all the transceiver algorithms as software for a processor. So software defined radio is a wireless device. So it can be consist of configurable RFN with FPGA or some programmable system on chip to, that is SoC, that is programmable system on chip to perform a digital function. Okay, here so software defined radio is a wireless device. It can be consist of configurable or a front end with FPGA or some programmable system on chip to perform a digital function. This is considered as the main reason why we are using the software defined radio. This is the evolution of software defined radio from the period of 1982 to 2020. First, they introduced 1G, then 2G, then 3G, 4G, but today we are using 5G concept. So what are the advantages of radio vision method? Means it requirement of image database and extensive image processing power. These are the advantages of radio vision method. So the benefit of using cognitive radio is it improved reliability, enabling broadband, improved communication structure, that communication with other networks. This is the main thing. Then backward compatibility, that introduction of new services. These are the benefits of using cognitive radio. So what are the main potential impact area of cognitive radio? So it attracts interest in various areas like military, TV white space, femtocells and cellular agility. These are the areas of interest in cognitive radio. It is very much used in the application of military oriented.